Hello everyone, welcome back. Today we will be discussing version control system. In simple language, version control system help us to keep the track of our project. Our project consists of multiple things, that is document, code, SOP, procedures. So this project document can be easily managed with the help of version control system. Primarily, developers use the version control system to keep the track of the code. Version control systems help us in all phases of product build lifecycle. Version control system help us in development to write the code and host that code on the version control system. So in the next phases, that testing suite can be created and can be hosted on the version control system. In deployment, we can write a script, auto deployment scripts, and we can make the script available on the version control systems. Making these codes available on version control system help the team to easily get the code and start doing the work without having the dependency on any system or any individuals. There are two major category of version control system. The first is centralized system and second is distributed system. Centralized systems has the project copy located on a single server which can be accessed by all the team. Centralized systems help developer to get the code anytime. Centralized system work on first come first serve basis. That means if I have placed my code and I am editing that code in the same file, another user won't able to do that. So at the same time, only one user can edit the file. Centralized system can be easily accessible to the team member and they can easily write their code and publish that on the centralized version control systems. Centralized version control systems avoid the issue of conflicts because at the same time multiple users not able to access the same file. Whereas in distributed system, we do not have any dependency on centralized system. Every developer has their own copy of their projects, so they can easily start their work without having any dependency to access any centralized server. In distributed system, all the developer can easily access their own file on their own local systems without disturbing each other codes. Centralized systems having the dependency on the server. If server is down, no one able to access the progress or the existing code. Whereas in distributed system, we not have any dependency on centralized server, since all the copies are easily available on their own local systems. In distributed systems, developer build their code and they can easily publish on the centralized repository, which we called as hub, and easily we called as a repository. And this repository are useful if we need the same code on our local machine. So anytime we can do the pull push, anytime we can get the code, anytime we can write the code on the repositories. So these two systems are widely used in the industry to manage the version of the code. There are various examples which work on centralized and distributed mechanism, like Git is popular and it's a distributed version control system. Whereas some Microsoft tools, which is widely used in the industry, they are centralized version control tool. Example, TFS. So in our course curriculum, we will be discussing the Git. Git is an open source version control system. So we do not have any proprietary code to get the Git. So anyone can simply install the Git on the various platform like Linux, Windows, Macintosh. Git have its own global repository we called as GitHub, and GitHub, anyone go ahead and create their account and use the global repository. So in our course curriculum, we'll see how to use the Git and also GitHub. So as we discussed, there are the different OS supported by the Git. So like Red Hat, we can run the command yum install git. On Debian base like Ubuntu, we can run the command apt-get install git, and here we'll download the exe file for Windows and just follow the wizard to install the git. And on Macintosh, we have here file to download the installable file for Macintosh. So all the operating system support Git. Git have a same command on all OS. So there is no change in the command and syntax and options on all OS. So if we are okay to work on Windows systems, so same command I can easily run on the Linux system. So Git do not have different set of command for different OS. It's have the single set of command that run on all OS flavors, whether it's Windows, Debian, Red Hat, or Macintosh. So how check Git is working or not? So if we install the Git and if we run the command git space version, so it will list the Git version and also the some helpful command. So if the output of this command looks fine, that means our Git is installed successfully. So if I go in Google and I type here, so here I can download the Git setup for Windows. And for Linux, we can start any Linux systems. So it takes some time to download, and meanwhile we'll start our Linux system. Hello everyone, welcome back. Today we are going to see the installation of Git. As we discussed, Git is a distributed version control systems. Git allows us to keep the track of our code. Why we need to keep the track of our code? So for example, if I have to come back on the previous version, I can easily do that with the help of Git. So version control tool help us to manage the code. So anytime we can come back on the previous code. Also we can have a number of versions of the same code. So based on our requirement, we can switch to the different version and we can use that version. So Git is a very powerful and popular tool to manage the code. So in this video, we are going to see how to install the Git on both operating system, on Linux as well as on Windows systems. So to install a Git, we can go in the Google and we can simply say Git for Windows. So it will populate the site git-sem.com in download. So I have already, so I will cancel the download. I have kept the exe file in my D drive under my Git folder. It's an executable file .exe, so we can just double click on that and it will start the wizard. So it's under general public license. So it's a no need to pay any cost or payment. It's not proprietary. So we have to click on next. Open SSH. So keep all the default option and just click on finish. So it will install all required files. Whereas to install the Git on any CentOS on Red Hat or Ubuntu, we can simply install it. If you are working on Ubuntu, we have to run the command apt-get install and git. And if you are working on the CentOS or Red Hat, we have to do yum install git. So this is my CentOS system. So here it's CentOS 7.3. So to install on this, first I will check whether it's installed or not. So say rpm -qa grep git. So it's have a lot of other gits packages. So to check whether git is working or not, so we say git version. So git command not found, that means git is not installed. So main package is not installed, so we'll say git install, so yum install git. So it will start the installation of git. Whereas on Windows system also installation is in progress. So it will ask to install the git. It have the one dependency, that is perl-gits. That's fine. We'll say yes, go ahead and install the git. So in installing all the required RPMs, whereas on Windows systems also completing the git setup wizard. So we'll say finish. So installation is complete and it's a release node. We can close it. So on the both system we have installed the git. Now how we will verify the setup installed successfully? So to verify it, we'll give the same command git space version. So it says 1.8, it's installed successfully. And on Windows machine, we'll say give the same command git space version, and it says 2.14. So on both system, we have installed the git successfully. Now what next? So when we install the git, basically git is a distributed version control system. So that means if I am working on the Linux repository, it will not going to hamper my Windows repository. So user can work on any operating system from anywhere and they can maintain their own local repository. And finally, if they are working for the same project, so this code they can commit to the GitHub, that is centralized repository, and from there we can maintain the code. All right. So first we'll learn how to set up a Git environment. So by default, Git is installed. By default, Git will not have any setup. So that means no user configuration is so far we have done on this both machine. So what is user configuration means? So for example, this is my system. This desktop is my system. So I will be working. So how anyone can recognize which user is doing this activity? Let's say example, I'm working on the project A and I have written a lot of code. I have created a lot of file. Then how this code will be identified which user has been created? So for that, we need to do the global configuration, whereas we have to maintain our username and password in global configuration. So whatever the activity we'll do on these systems, so that get attached with that user. So that means if I will see the log, I can easily identify user X have did this activity because that username and their email ID get associated with that all activity which user is going to be performed. All right. So here to do that setting, first we have to run this command git config hyphen hyphen global. After that, we have to say user dot name, and here I will say username Ajay. Hit enter, and same another command will say git config hyphen hyphen global. Will say user dot email, and here I will say Ajay dot DevOps at hotmail.com. All right. Now I have done with this same thing. I will be working on other systems also. So here on Linux machine also, I can make the similar uh, similar setup. But here, let's say example, we'll do the setup for other users. So this two systems will help us to identify their identity by different name and email ID. So when we will be working in the projects, in that case, we'll have the advantages of two different accounts. So we'll see that how two user works on the same repository, what are the activity they are doing. So here we'll configure this system with a different user account. So we'll say git config hyphen hyphen global. Here we'll say user dot name, and here I will say name DevOps, and another will say the email ID git config hyphen hyphen global user dot name. Here we'll say Ajay dot mscit at gmail.com. All right, so I have set up two different accounts. These two different accounts help us to do our test cases. So this will help us in future labs to use these two different accounts. All right, so we have installed the Git on Linux as well as on Windows system, and we have set up the name and the email ID on both the systems. So what next? Next, we can create a repository and we can work on that repository. So that we'll see in the next video. Thank you. Welcome back. In this video, we are going to see Git repository. As we discussed, Git helps us to maintain the version of the code. So how basically Git works? To understand the Git flow, we'll understand this flow. So at the very initial, we have the working directory. So working directory is a local directory where we maintain our code. Let's say example, I have the project 1, and in project 1, I have the 10 number of different code files. So that 10 files will be residing in my working directory. So from my working directory, I will use the command git add and add into the staging area. Now, what is staging area? Staging area is a testing area where we have just put that all the codes for testing purpose. If it is works fine, we'll commit it as a final commit, and that will go into the repository. To understand the staging area, let's say example of Amazon or Flipkart, where we add the product into the cart. So once we add the product into the cart, that means our decision is not finalized. We have just put that code or put that product for our review. Once we do the review, maybe we'll add or we'll remove the some product, and finally we'll take a decision. We have to go with this product, and we do the checkout where we make the payment, and completely we close that deal. Same thing in the Git also. Staging area is a review section where we review it. If our review looks fine, After that, we'll do the commit. In commit section, we'll use the command git commit, and that will push the code into the local repository, and that will make the version of that code. So let's say example, if I have add the comment like version 1, version 2, whatever, so that will get associated with that commit. So every commit have the version. So let's say example, if it is my first commit, maybe I will write my first commit, my second commit, my final commit. So and so forth. We can add a number of comments to each commit. So later on, if we have to come back on the previous code, we can easily do, because we have the n number of versions available in the local repository. Once our local repository is available, and if you want to share with all teams, all members, we can use the remote repository. Remote repository accessible to everyone. So once we push the code from our local repository to remote repository, all the team member can easily access same set of files or same set of code on their local machines. So in this way, we can start from working directory, staging area, local repository, and remote repository. So to get the code, we'll follow the reverse order. So from local repository, we push the code, whatever goes to the remote repository. Same thing we can bring back to our local repository, and again we can bring back to our working directory. So this all we are going to do practically in our lab sessions. So very first, we'll see how to create a working directory and how to create our own local repository. So to do that, I will come on my local system. Here I will create a directory mkdir project underscore DevOps. So this is my project I have created. I will go inside this, and now here I will do dir. So I do not have anything inside this. All right. So first I will create my project. So my directory is created. Now to create our own repository in Git, it's very simple. We have to do git init. So it will initialize the Git and it will create a local repository. So what it says, in this directory d drive project underscore DevOps dot git is created. All right. So dot git is a hidden file. All right. So if I do dir, so here I cannot find because it's hidden. So I will check from other way. Project DevOps. So this is created, and this .gits contain lot of different folders and files. So this folders and file is a local repository, and it's contain the metadata and other Git information. All right. So whatever the activity will do, that is going to save or maintain in this metadata area. All right. So now we have created our own local repository, and .git ensure that repository is created and all metadata is created. All right. Now what next? If we type the command git status, so it will say no commit yet. So we have not committed anything so far. All right. So let's say example, if I start writing my one program, and let's say example, if I open the notepad and do the new, and here if I write test file, all right, and just will save this in the same directory d drive project underscore DevOps, and here we'll give the name test.rb. RB stand for, let's example, it's a Ruby file, and we'll do dir. So here we have test.rb. Now we'll again give the command git status. So here it says no committed, untracked file. What is untracked file? Untracked file, in working directory, we got an file, but it is not controlled by the Git. So far, no versions is attached, and that's the reason it says untracked file. So to track this file, it's give the command git add file name to include that will be the committed. So basically, if we run this command git add, it will take the file from local directory and make it into the staging area. So let's put this file into the staging area. So we'll say git add and file name. So we have the test.rb. All right, now we'll run the again git status command. So it says changes to be committed. So it's not at committed. So it says now if you see this green color here and the file name, this is a staging area. So we have bring that file from working directory to the staging area. It will, does it remove from the current working directory? No, file will be there, but now the track we are maintaining, and now we have pushed that file from local repository to staging area. So what this command means, git rm cached file name. So if we are not okay with this version of the file, and maybe we want some changes, like we have written test file, or we want something different, so we can delete it. We can again remove it from the staging area. So to remove it from the staging area, we have to run the command git rm -- cached and file name. So this command will remove from staging area. Again, it will come back in your working directory. As of now, we have push that file from working directory to staging area. Now, if we have to push from staging area to committed stage, that is in the repository, we have to run the command git commit -m. So this is very important. Comment is very important while committing it, because without comment, version cannot be attached to that file. So I will say this is my first version of code, and after that file name is a test.rb. All right, so it says file 1 changed and 1 insertion. So 1 file is added. All right, now again we'll run the command git status. So here it says nothing to commit, working tree is clean. So that means whatever we have in the working directory is successfully committed. As of now, no activity is pending to do. That means successfully we have added from working directory to staging area, and from staging area we have successfully committed to our local repository. Thank you. Hello everyone, welcome back. In last video, we have seen how to create a project, how to commit the code into the local repository. So if we run the command git log, we can check the status of our local repository. So here it says we have one commit, and that commit we have done in the master, and the author is Ajay, and the email ID is ajay.devops@hotmail.com. When this commit has done, it's done on the date we just mentioned here and the time, and the commit message is this is my first version of the code. So this detail we can check with the help of Git log. Let's say example, I want to do some modification in the file. So I will go in my file and will open in the any editor, and let's say example, I have written this is another version of my file I have just edited. So We have written some messages and we'll close the file. And now if we run the command git status, so here now it says modified. So it says changes not staged for commit. So this changes is not so far staged and it's not committed because the file which we have committed is the previous version and now we have some modification into the same file. So repository have the previous version, but the recent change we have made, it's not committed to the local repository. So how we can update our local repository with new changes? Before we do the changes, we want to know what local repository have. All right, that means whatever the file we have committed, what data it's contain, and what is the difference between the committed file and non-committed file. So we can check this with the help of diff command. So if we run git diff and after that file name, so in our case file is test.rb. So it says some data is edited. So if we can see here test file, this is another version of the file. So this is plus sign, that is edited one, and this one is the previous data. So it says whatever the changes we have done, it will highlight here. So let's say example, we have the thousands line of code and in that we have made some changes. So we can compare it, our working directory with the committed directory. It will give us the clear picture where the change has been done. And easily we can get to know whether we want to commit the existing file or not. So let's say example, the existing file that is working directory have this content and the previous content is above the red one. Now we want to commit that. So the procedure remains same. We'll run the command git add and after that the file name. So its file name is test.rb. Now we'll again run the command git status. So it says modified version of our file now available in staging area, but so far it's not committed. So let's run the commit command -m. So we'll give the new message and after that the file name. So it says one file change and two insertion, one deletion. So it will take care and it will bring that file to the current working directory. So based on this message, it has added the two lines and deleted the one line, and now working directory is exactly saved to the local repository. Now both the files have the same content. Now we'll run the command git status. So here we'll see that nothing to commit. That means whatever we have in our working directory is already committed. So the test.rb, the changes or modification we have did, it's already committed to local repository. Now we'll run the git log command. So it will tell us there is a two commit has been done. The first commit message is this is my first version of code and the timestamp is attached. And the another commit is done at the another day and the timestamp is attached with the commit message. This is a second version of code. Another way to read this commit lines, we can give hyphen hyphen one line. So it will just give us the short hash code and after that the both commit messages. So we have done the two commits for this same file. So in this way, we can use the git diff command to make sure or to compare it, the committed code and the current working code. So based on that, we can take the decision whether we want to do the commit of our modified file. Thank you so much. Hello everyone, welcome back. In this section, we are going to see the commit. So Git have different types of commit. So here we are going to use Git bash. So this console, what we are seeing here, it's a Git bash. So when we install the Git on Windows, we get the Git bash by default. So the font looks good and the colors looks good in the Git bash. So now we'll first hit the command git status. So here we see that 2 files are in staging area and 2 files is untracked. Let us first add all the file in the staging area. So we'll say git add and the dot, and after that we'll run the command git status. So all the files are in the staging area. Now let us do the commit. So we'll do git commit -m. This is my third commit. So all the file those are into the staging area got committed, and it says 4 file change and 4 insertion. Now we'll run the git status command. So working directory is clean. Now let us check the log. We'll say git log -one line. So here we'll have 3 commits. So it's showing the currently the head is at the master, all right, and with the third commit, and we have the SHA code for second commit, we have the SHA code for first commit, and this is a recent SHA code created for the third commit. All right, now let's say example we have less we have multiple files here. Now we want to bring back this file and have to do some changes and again want to commit it. So I do not want to maintain the file which is already committed. I do not want that the code should be get committed. So I have to come on the previous version. All right. So to go backward, if the file is already committed, we can do that in Git. So let's say example, I want to come on the previous state, which is already committed. So I will say git reset. There is two different types of reset. One is hard, another is soft. So here we'll try the soft. So soft means it will bring back the last commit. So last commit was for the three files. So I will just scroll up and check what was my last commit. So my last commit was this third commit, and in third commit we have added the 4 files, right? So it will reset the last commit. So it will remove this commit. All right, will come to this stage. So we'll have only 2 commits. So 1 caps means you are coming back of 1 commit. 2 caps means you want to come at the second one. So if we put 2 caps, that means you want to reset these 2 commits. So you will be at this position. Let's say example, I want to come back on the previous state at this position. So I do not want the last commit which we have did. All right, so we'll hit enter. And now we'll check git status. Previously, the working directory was clean, nothing to do. Now we'll check, and now it says there is a 4 files in the staging area. How the 4 file is now in the staging area? Because we have reset it. We have reset our last commit, and we are now on this second commit. So that's the reason in last commit we have added this 4 file in the commits or in the local repository. So there were no file in the staging area, but after reset, it's bring back this 4 file in the staging area. All right. Now let us check the log. So we'll say git log hyphen hyphen one line. So we can see that our head is on second SHA code, where third SHA code is no longer exist because we have reset it. Now from staging area, how we can go back? So the same command we have used before, the same is git reset, and after that head. And if we want to give the file name one by one, that is also fine, and we can just give the dot. So it will take this all file from staging to working directory, so it will become on stage. So we'll run the command git status. So we can see that no files in the staging area, but there are the 4 untracked files. So this file were already committed. We bring back from commit to stage, and from stage we have bring to our working directory. So this file is no longer exist in the staging, as also it will be not exist in the final commit. So in this way we can do the reverse or rewind our the commit code. Now let us understand how the hard reset works. So let's say example, I run the command git log. So in log I can see that I have 2 commits. So we'll say git hyphen hyphen one line. So 2 commits. All right. Now let us use the same command, and with a different option is hard. So we'll say git reset hyphen hyphen hard, and after that head. Now again we have to decide which commit we have to reset. So this is the second version of the code. All right. In second version of code, we have done some changes from the first version. So we have updated the file in the second version. So if we reset it, what's happened? Now let's check that. So we'll say, I want to only include the first commit. As per the current number of commit, just we want to include the first one. That means this one. All right. And after that, we have to hit enter. So now it says head is now at 3C 3FA29. That means this. The previous head was on this, but now it's on the 29th one because we have reset it from 1. So from 1 means it head will come on the 29. So we can check that in the git status. So let's just run the git status command. So this was the previous thing because no longer this file is in the staging area, that's fine. But we have not got any unstage message for this. So what's happened? So nothing is in staging area also. But in the soft commit, we have observed that once we do the reset, the file, the committed file come in the staging area, but here we can't see any file in the staging area. So what it means? It means it will unstage it automatically. So it will uncommit it, again it will bring in the staging area, it will remove from the staging, it will bring to the working directory, and it will just remove that update also. So this was for the file which we have created. And now let us check the what are the file we have. If we remember the first file which we have created, it was the old file test.rb. All right, so now let us run the test.rb. So it's only returned test file, but we remember that the message of this file was two-liner where we have entered this is my second version of code, something like that, the message we have entered. But that message is now reset to the very initial because now the head is on the first commit. So this is completely removed. So this commit is completely removed. So it have changed the file also. The file was, for this commit, the file was test.rb. So now the test.rb is in the first version of the code. So second version of the code is automatically wiped out. So this code, whatever the changes we have made at this commit, it's not only unstaged, but also it will go into the file and remove that all the content, and it will make the file available in the first version. So the file will be completely going to be first version of the file. So hard commit is very, very dangerous because it will not bring that file in the unstaged area. It will go beyond that. It will go in the file and remove all the content, and it will make the file available in the initial version of that file. So what is the initial version? So initial version for us is 29. So here we see the message when we have reset it to the hard, it's given the message head is now at this. That means our file is now reset it to this mode. So this mode was the first version. So that's the reason when we read the file, we are getting the simple message that is test file, but we are not getting the another message that we have written at this stage. So this stage is completely wiped out, and we are not getting any content of this commit. So in this way, we can use the soft and hard commit, soft and hard reset for the committed code. So soft and hard reset we can use in the various occasion where we require that we have to rewind it and we have to do some changes and we have to again commit it. So soft reset has the advantages. It will bring the file into the staging area, and from that we can take the decision. But in the hard reset, it will completely remove the content and the file will be come to the initial version and the code is going to be automatically removed. So in this way, we can use the Git soft and hard reset. Thank you so much. Hello everyone, welcome back. In this video, we are going to see GitHub. GitHub plays an important role in version control system. It allows us to share our code with other team members. It allows us to access our code from anywhere, from any devices. GitHub publicly available for anyone. So we can use a GitHub to maintain our code globally. So any team member can be easily pull the code and can start working on the same set of codes. So we are going to see that how we can use the GitHub to manage our code. So we have to create an account on github.com. And once we create the account and sign in, we can see our profile here. All right, so this is my profile. It's a new profile. And here I can see that all the detail related to my profile. So I will go on the home page and it will ask us to create a project. So I will just click on start a project, and here it will ask for repository name. So I will give the name dev-git. Now here we can give the description, which is an optional. All right, so here it will ask what type of repository it is. So it's very important to understand if you are contributing to everyone, so that will be public repository, so anyone can access and see the repository. So this is a contribution to your social people, those who are working in the same field. So maybe you are working on the Java project related to some AI, or you are working on the cloud project and you want to share your work with folks, those who are working in the same area. So we can choose the public. In public, it can be accessible to anyone, so no restrictions because it's a contribution. Another one is private. So if you are limited to your organization and it's very private for your organization, so those kind of code we can keep in the private. So at the same time, we have to pay the charges for the private repository we are creating. So we need to fill this whole detail for private repository. All right, and after that we have to say create a repository. So it will create a repository for us by the name dev-git. So at this time we are going to take a public repository and we'll say create repository. All right, so once we click a create repository, it will create a repository for us. So this is my account sign in name. So this is a name from which my account is logged in. So it's a DevOps-CS, and this is a repository name / dev-git. All right, so it will give us a lot of information on the first page. At this time, we do not have any request, no pull request, no project, no wiki. All right, so what we are going to do here, so whatever the code we'll write here on our local machine can be easily pushed to our global repository, and this global repository is accessible to all developers. So they can pull this code from any device, from anywhere, and they can start working on the same project or same set of codes. All right, so what it asks, first you need to do the git initialization. So if we have already done, so we can no need to do that. Let's check the status. We'll say git status. So it will give us the status. So it says untracked file. So at this time, Git is initialized because Git command is working. So no need to run the again Git init because Git is initialized. But we can see that there is a set of files which is showing in untracked. So let's add it, that file. So we'll say git add, and we'll say asterisk. So it will add all the files, and we'll again hit the git status. So now it's showing in the staging area. Now it's asked us to do the commit. So to do the commit, we can run the command git commit -m, and we'll say new version of my code, and we'll say here 1.1. All right, so now it's committed. We'll again run the git status. So it says nothing to commit, working tree clean. So that means whatever the file present here in our local repository, it's already committed in local database. It's not committed on the global database, that means GitHub. All right, so it's limited to our local repository. Now what to do to bring those set of codes on our global repository? So it's given the command we already committed in the local repository. Now it's asked, first we need to add the remote repository. So this is a remote repository. The name is dev-git. So we need to add this on our local machine. So whatever the push will going to do from our local system, it will directly come in the global repository, that is a dev-git. All right, so we'll say git remote add origin. So our origin is this link, and this link point to our this repository. All right, but here we need to understand there is a two set of commands are available. One is in the form of SSH. So it's highly recommended if you are working on the Linux boxes, and HTTPS we can do on the Windows system. So this screen is on the Windows system, so we'll use the HTTPS. That's fine. We'll copy this. What exactly it's pointing? It's pointing to our global repository. So git remote add origin and HTTPS GitHub and my user ID, and after that my repository name. That's it. It's not very difficult. So we need to give the github.com, and after that username, and after that our repository name .git. That's it. And the command is git remote add origin and the complete URL or repository. That's it. Now we have added it. So now how we'll check that whether it's added successfully? So we need to run the git command with remote, git remote, and verbose v. Now it shows here this repository is added, and we can do the fetch, and also we can push. So both operation we can perform on this repository. That sounds good. Now what next? It asks us to push the code on our master. So by default, when we create a repository, it's create a branch with the name master. So whatever the push we are going to do, it will go in the master. All right, so we'll say git push -u origin master. Now it's in progress. So whatever the local repository files or codes are available, now it will going to push on the GitHub. Once the operation complete, we can see that now it's asked for the credential because we have not logged in on our local system on the GitHub. So we'll provide our credential here. So it's a username, and after that our password. All right. Now what it says, delta compression using up to 4 threads, writing object 100%, 9 out of 9, and the byte is 675 bytes, and the speed it's showing, and it's showing the complete URL where we have made the push, and after that it's showing the branch name is a master, and after that it's showing the branch master setup to track the remote branch master from origin. So from origin, now it's tracking, or now its head is on the master. So from our local master to our GitHub master, the push has been done successfully. Now let us check from GUI from the GitHub. So we'll go in our repository. Now here we can see that all our files are available, and it's showing us the timing here, what time this push has been met. So it's 4 minutes ago, and it's showing as the comment we have written in the local repository. So it's showing as the same comment. So version comment is remain same. All right, and as of now we made 2 commits and 1 branch, because it's a master branch itself. No other branches we have created so far, so that's the reason it's showing 1 branch. And here contributor is 1. So this is how we can push the code from our local repository to GitHub. Thank you. Hello everyone, welcome back. In this video, we are going to see how to use Git clone. Suppose that we have a set of developers working on some particular project, and the developer having a system with the name Dell. On this Dell system, already have the project code. All right. At the same time, a new developer joined the organization, and he is a Unix user, and his system name is Worker2. But he is very new user to this project, and he do not have that same set of codes. But that code is available on the GitHub here, right? So how the new developer get the same set of code? So by using Git clone, new developer can easily download all the files of that particular project. So we'll say use SSH, and we have to copy this link of our repository. Our repository name is dev-git. All right, and it's have the same set of codes what existing developers have. So we'll come here, we'll see here the command git clone, and after that URL, and we'll hit enter. It'll say, do you want to continue? We'll say yes, and it gives some error related to our public key. All right, so in that case, we'll say ssh hyphen keygen, and we'll hit enter and generate a key for our system, and we'll again hit the same command. All right, it's having some key issues, so we use the alternate here. We'll use the HTTP, and we'll try to download it again. Now it's completed. So here it seems some public key issue, so that will troubleshoot later on. We have successfully downloaded that project codes. Now what it did, it's a very new user, definitely Git local database is not available. So when we run the Git clone, it's create a local database as well. So it run the by default git init command in the background. And after that, it's create a directory structure for us. So it will create a directory structure. So we'll say cd DevOps -git is created by default. And in that, all the project code is downloaded. So we'll see here all the project codes are available, and we'll see here ls minus a and .git directory is also available. So in this way, we can use a Git clone to get all the source code of our project for any new user. All right. Thank you so much. Hello everyone, welcome back. In this video, we are going to see the use case, how multiple developers work on particular project using Git. Let us assume that we have one project and that project is stored on the GitHub by the name DevOps-CS. And this project have one repository called as dev-git. And there are multiple files inside that repository. Now, if any user want to work on this project, they can do the git pull and start working on the project. Let's say example, we have two users. One is operating on Windows machine and he have the same set of file as on the remote repository. Another user, we have the Linux user and we'll log in the machine. All right. So this user also having the same set of files. Now we'll make sure which remote repository they have configured. So for that we'll give the command git remote -v. So it says that dev-ops-cs and they are referring the repository dev-git. So whatever the pull and push, that is fetch and push, will do, it will go on from this repository. All right, let's come on the Windows machine. This is our Windows machine. Here we'll run the same command git remote -v. So it also lists the what remote repository they are referring. So both the users or both the systems referring same remote repositories. Now we are going to demonstrate how the issues occur when the users work on the same file. Now let's assume that you have two users. One is working on the file called as web.py locally and other user is working on some different file. But due to dependency, other user will also want to change the web.py. In that case, it will create a problem because both users have made the changes in the same file. All right, let's say example, Windows machine user is working on web.py. So we'll open vi web.py. It's allowing vi because we have working in the git bash. So let's assume that I have made some changes here. I will write here this code is all right. So I have just written one line of sample code and I have saved the changes. Now if I do git status, it will show one file is modified, that is web.py. Now both users are working on their local repository, so there is no problem, right? So let's say example, a Linux machine also made some changes in the same file and it will say so it's just sample line we have written and we have saved the file. Now when this system will run git status, it will show the same modified file is web. Now what we'll do, we'll ask the Linux system to commit in the local repository. So let's do that. So we'll run git. Now we can do this using a single command. So we'll say git commit -a -m and I will say this is my version 1 from Linux system. So this is my version 1 commit from Linux system, and I have made this commit message. So it says unable to auto detect the email ID. So we have to configure this above one, because the first time this user making the commit. So we'll write the above command. So git config -- global user dot name. So I will type the user as Divesh. All right, and another thing, we have to configure the email ID. So git config -- global user dot email, and here I will type the email ID. Some email ID of user Divesh. All right. So this will happen because this user is pretty new and he has not configured any global settings. So because to trace the detail of each commit, Git needs a email ID and username. So it will attach that commit to that username, so they can identify later on which users commit these changes. So let's try our command again. Now it says file change is happened, and now let's see the Git status. Now it says nothing to be commit. So nothing to be commits because everything is clean. So whatever the changes we have committed in the local repository, now will come on the Windows machine. Now Windows machine is not aware that someone is already working on that, and he's also started working and already made the changes. Now he also do the commit. So he will run the command git commit -a -m. This is v1 from win system. All right. Now the changes is saved in local databases, local repository. Therefore, so far no issue, because this user made the changes, Windows user, and committed in the local repository. Linux user made the changes and committed in the local repository. So far no problem, because both user is working on their local repository. Now let's assume that this user feels that his change is right and he want to push to remote repository. All right. So what he will do, that he will just type the command git push -u, and after that where we have to commit. So as of now we do not have multiple branches, we have only master. So we have to write origin when we are committing to the remote repository. So we'll write origin space master. All right. Now it's asking for the username of Git where we have to do these changes. So we'll take this here. It's DevOps -cs. And now it's asking for password. All right. So we have successfully pushed our code from local repository to remote repository. Now see the changes. We'll open the web.py. So this change is done from Linux system. So this is what we have changed. Now Windows machine is not aware some developer worked on the same file and made the changes, because he feel that He is working on that file and no one is working on that file, so he is not aware. All right, and he made the changes in the local repository. Now this user, that Windows user, also want to push that code on the remote repository. Now what Windows machine will do to push the code on the remote repository, he will use the command git push -u, and he's also doing the push to the same branch, that is master branch. So we'll write origin master. All right, now it takes time, but here we get message rejected. So what it means? It means whatever the file this Windows machine is trying to push, it's already updated. So last update is already happened. So this file is most updated as compared to the Windows machine. So that's the reason Git is not allowing this user to do any push, because already this file is got changed, and this file what Windows machine have, it's have the old file. How it is old? Because is not referring to the local repository, it's referring to the remote repository. Remote repository have the latest file, and that is pushed by the Linux user. And now Windows user have the old file, because this changes made on the local repository, and that changes this user, Windows user, is trying to push on the remote repository. That's the message he is getting, is rejected because failed to some push refer to this. It's a complete path where we are doing the push, and update were rejected because remote repository contain works that you do not have locally. So whatever the update remote repository have, it's not updated on the Windows machine. So that's the reason straightforward Git rejected this change, because it's not the same file, it's not the same code that you are making the change. So what is the problem? Try to understand. It's pretty simple. So when I do cat web.py, so what it says this is code created from Windows machine. So this line, when it's tried to compare this line with this code, it says it's different, and this one is a different what you have. So that's the reason it's got rejected, because on the same line it's find out the different changes. So that's the reason it's not accepting the Windows code to do the push. So how to solve this problem? This problem is basically this window have some different lines which is not on the repository. So it will ask you first get this sync with your local file. So when I have the same this file, remote repository file on my local repository, then I can make the changes and do the push again. I cannot immediately erase this and write my code, because this is already pushed and we do not have these changes on our Windows machine. So straightforward it says it's not locally, you do not have these changes so far. Previously it happened, previously you both machine have the same set of code, anyone can do the push, that's fine. But after making the change, we not did any pull. That means we not sync up with remote repository, and we directly tried to push it, and by the time someone is already updated the remote repository. All right, so in this case, to resolve this problem, what we have to do, we have to first pull. So we'll say git pull, and after that, from where we have to pull? So we have to pull from the remote master repository. So we'll say origin master. Now it will pull all the file. So the change one is web.py. When we pull it, we get a message saying that conflict. So what is a conflict says? Conflict says on the same line I found the two changes. One is yours, and one is which is coming from the remote repository. Now I have to see what are the different changes, what are the different conflicts is happening. So for that, we have to run the command git diff, and after that the file name. So our file name is web.py. Now it says that here we have two lines. One is this code is created from Windows system, and one says this change is done from the Linux system. So on the same line, it found the two changes. Now it's our call which changes we have to keep. All right. So now we have to do this manually. We have to make sure either this change would be correct or this change would be correct. Why we are thinking like that? Because this change is happened on the same line. On the first line, one machine says it's a Windows update, that is this code is created from Windows. Another user, other system says this is done on the Linux system. On the both line, we have the two lines. Now we have to say to the Git, this is what the final change is. Now make the commit. So to do that, what we have to do, just we have to open the file. Now we have the changes, but it's happened in the conflict mode. It's not the correct file. It says the file is downloaded, but it's conflict. So that's the reason it's added like that. So we will open our code web.py and we'll see that. See, because some extra code is there, so we'll delete this. Head is not required. Now how our line is required? Do we require like this? All right. So I will come on the second line, delete it. I will come on the third line. Oh, undo. Second line, delete, and third line, delete. Now do we want in this manner, or do we have to remove something, maybe the first line or second line, or do we have to alter it? The second line should go up and first line. So what I want the first line should be a top. So I will come on the second line, I will say YY, and I will just paste, I will just do the copy of first line YY, and I will paste here. I do not need the first line here, so just I will delete it. So I need the first changes of the Linux should be at top and the Windows should be at down. All right, so I have corrected it manually, what things is required and what things not required. Now I am okay to go with final commit. So now what I will do, will directly go and add this file in the local repository. So we'll say git -a space -m, and we'll say commit here, and we'll say resolved the, what we have resolved, we have resolved the conflict. All right, now once we resolve the conflict, the above conflict, where we got the conflict, this one. So this we have now resolved by doing the manual changes. Now we'll commit in our local repository. Now we'll try to git push. Where we have to push? We have to push to our remote repository, that is origin master. Now this time it will not give you the error because we have corrected it. Now on this, now we have the latest update and we have pushed it to our remote repository. Now we'll come here and we'll see the changes. We'll see here these two lines is same as we have updated just from the Windows machine. Now what Linux system will do? Linux system will have the old data. All right. Now Linux system have to just pull it. So Linux system will do git pull origin master. So it got the recent changes. Now when we do cat web.py, so it got the recent changes. So this is how we can resolve the conflict issue in Git. Thank you so much. Hello everyone, welcome back. In this video, we are going to see the branching strategy in Git. Let us assume that we are working in the software development, and it is very important to understand how Git works in software development process. Let us assume that we have here multiple branches. Now, why we need the branch? Why we need these multiple branches? What is the role of this branch? And top of this, what is branch basically? All right. So to understand this, we'll use this use case, how basically this branching is works in software development process. So let us assume that your actual code is at master branch. So the live code, the running product code is always with the master branch. The development team usually not directly work with master branch. All right. So if I am a developer, so I will not get the direct access to work or make any changes in the master branch. All right. Because master branch is the running code. So the running code cannot be directly touched. So it's have the processes have to go through that. Right. So every organization have the release manager. So release manager duty is to do the testing and after that fix all issues. If works fine, then it goes to the master branch. All right. So that release process we follow to release that code from any stage to the master branch. So maybe you are from the host fix or from the develop branch or from any other branch. We cannot directly merge into the master branch. So we have to follow the some practices, like we have to do the testing, we have to do the QA, and after that we can merge with the master branch, because master branch is the running code of that product. All right. Now let us understand, if you have already some softwares which is already working and someone find that issue. Let's say example that software is fine, is on Android but is giving some problem on iOS, and they reported that issues. So immediately what development team will do, they will have one hotfix branch. That hotfix branch going to work on that bug, and once they find that this issue is resolved, they will merge that code with the master branch, and they will write a note to the user saying that iOS platform issue is resolved, so that users can freely work with that software on iOS as well. So this hotfix branch is to solve the quickest problem which arise in the production environment. Now we have here number of features branch. This features branch is keep developing. This developer work on the features. Let us assume that we have company where we have the development process, and development team have the call weekly basis, and they decided that every week they have to add some feature into their product. So the feature branch, they will work. So every week they will make number of changes and make available new features in the product. So those changes is added in the feature branch, and this feature branch is goes to the develop branch. So basically this develop branch is for the whole development. So developer write their code and push it on the develop branch. Let's assume that I am a developer. I am working on the feature XYZ, and this is my feature branch. Another developer may be working on the feature ABC, and he will work on the another feature branch. Like assume real time, someone is working on the login form, someone is working on the payment form, someone working on the payment gateway, someone is working on the users interaction. So number of modules they will work on, so number of branches they will create accordingly. So this features is going to be added in the features branch, and this features branch is going to be added in the develop branch further. All right, so this develop branch have the process to release their code into the production by using the release management process. So from develop branch it will go to the release part is to do the testings. So once the testing completed and they find that no issues, so they will release that code into the production, and they will say that version 1.0. So it was previously 0.1, now it's become 1.0. That is new releases came in. So how the new release came in? From feature branch, multiple features added, and that feature goes to the develop, and after development they follow the release management practice, and they have built another. So in release management practice, they have to take care all the checklists. They have to make sure everything is fine as per their decided checklist, and once it met it, the product release or the feature release into the production environment. And here we can see the minor changes, because it's not a major changes, it's not a feature added, that's a for it's only release number is changed, it's from the 0.1 to 0.2, but here it's a feature added, it's a big change. So that's the reason the version of that product is changed from 0.1 to 1.0. So in this way, the branching strategy works. Thank you so much. Hello everyone, welcome back. In this video, we are going to see more on Git branch. So in last video, we have seen the branching strategy. In this video, we are going to do practical of the same branching strategy, why the branching strategy is and how branching strategy works. Let us assume that I have number of branches and I have to list out all the branches which is created. So I will say git branch. So what it says it's not a repository. So we have to go in our project repository. Because in that directory git is not initialized, that means local repository for that directory is not created. Let us again give the same command git branch. So it says as of now I have only one branch, one local branch, and my pointer is also pointing to the my master branch. Now I want to create another branch, so I will say git branch and branch name. Let's assume I need dev branch. So we have created another branch, and to list this branch we'll say again git branch. So now it's showing us two branches, one is dev, another is master, but my pointer is pointing to master branch. So I have two branch, but currently whatever the changes will do, it will go to the master because my pointer is pointing to master branch. Now let us assume what are the content we have or the code we have in our current working directory. So we have here number of files in the current working directory. So if you want to switch from the master branch to dev branch and want to do some development, like for example here we have master branch here and now we have to switch here, to the development branch. All right. So how to switch it? So we'll say git checkout dev. So it will say switch to branch dev. Now we'll say the same command git and git branch. So it will say you have two branches, but currently your pointer is to dev branch, right? Why? Because we have just switched from master branch to dev branch. And here we can see all the files. So now this is very important. Why we are able to see all the files which is in the master branch? So by default in the Git, it's have the behavior to show all the files of master branch to the development branch or the sub branches. So whatever the things we'll see in the master branch, by default you will get in the development branch. All right. So here, that's the reason what are the files or codes available in the master branch in the current working directory of the project, we can able to see that. All right. So it will not restrict us. So if I say git status, so I will say on master branch, nothing to commit because these all the things are already committed by the master branch. All right. Now let's create one file vi. I will create a test file test.rb. I already have that file, so let's change the name. So we'll say foo.rb. This file created by dev branch. All right, we'll save the changes. Now we'll do the ls. So we have one more file called as foo.rb. Now we'll run the command git status. So it will say one new file is there and it's an untracked file. Now let us add this file into the staging. So we'll say git add -- all. So it will run add the new file. So it will go into the staging. Now we'll do the one commit. So we'll say git commit -m and we'll write this commit done by dev and we'll give the enter. So now we'll check here. So it says nothing to commit, working tree is clean. So we have successfully added the foo into the dev branch, right? Because our pointer is to dev. So whatever the commit we are going to do, it will going to be commit in the dev branch. So here the in message also you can see that is done by dev, and after that here the file is changed, and here we can see the dev. So it's currently this changes is done in the dev branch. All right. So let's check out to master. So we'll say git checkout master. All right. Now we'll do ls. So here we cannot see that file which we have created foo.rb, but it's there in the current working directory. So this is a logic. Whatever the changes will do in the development branch, by default, it will not go into the master branch. So that's the reason when we have checked out to the master branch from development branch, from the dev branch, changes will by default not get merged into the master branch. So if we again go to the dev branch and if we do the ls, so we can see that foo.rb in the dev branch, but same foo.rb is not visible or it's not there in the master branch. The reason is that same whatever the changes will do in the development branch will not by default or automatically merge to master branch. That we have to do because it's very sensitive. We cannot do every code, we cannot release each and every code into the master branch. So for example, developer done the lot of changes, so that changes should not go into the master branch automatically, right? So that is things release management come into the picture. We have to cross check everything, and after that we have to merge those changes into the master branch. All right, so in next video we'll continue with the same branching part. Thank you so much.